Again, this is for Math 60, Section 4.3 lecture. So we have another example. I guess this is example number 2. And again, we have a system of equations, so kind of let's look it over. We've got a 5x minus 4y on the top, 3x plus 2y in bottom, so nothing is matching up like it did on the first example. But I do see something that I like right here. This is a negative guy and this is a positive guy, so it might be kind of helpful to have that set up. Now, we learned a long time ago that when you have equations, the cardinal rule is whatever you're going to do to an equation, whatever you do on one side, you have to do on the other, and then it will remain balanced. But and so we want to make sure that we absolutely do this. And what we would do lots of times is when we had a fraction involved in our equations, we would clear out the fraction by multiplying both sides by the numerator. Well, what I'm going to do on this guy right here is if I take that whole guy and I multiply him by 2, that's going to create a positive 4y right here. And then when I add these guys together, that guy is going to drop out just like it did on the first example. And that's what I'm showing you right here, that I'm going to be multiplying this whole thing by 2. So I copy down the first one because there's no change. And when I multiply the second one, it turns out to be 6x plus 4y is equal to 14. Now I'm ready to add. 5 and 6 is 11x. These guys drop out. 19 plus 14 is 33. Divide both sides by 11, and x is equal to 3. So there's the first part of my answer. The first part of my answer. There's my x component, and I'm going to now be looking for my y. And I get to take this, and I get to plug him into either one of the equations. Now, the truth of the matter is I can plug it into this one or this one, but lots of times it's a good idea to plug it into the originals. So instead of using this one, I might want to use that one. But it's a decision that you're just going to have to make. So I'm going to pick this one, this guy right here, 3x plus 2y equals 7, and I'm going to stick that 3 in there. And there it is. 3 times 3 plus 2y is equal to 7. So this is my 9, 2y, and a 7. Throw the 9 on the other side, and I get a negative 2. Divide both sides by 2, and I get a negative 1. So there's my second answer, the second part of my answer. And of course, especially if you were taking a test, you would want to check this. So now I'm going to quickly go through example number 3. I think I have enough time. Let's take a look at it again. The only thing that I see that's kind of appealing is here I have a positive and a negative. So I kind of like that. But I can't just take one of the equations and multiply it by something and it's going to drop out. But what I can do is I can multiply each of the equations by something. So the least common multiple between 3 and 10 is 30. That's my least common multiple. So in order to get 30, this whole guy has to be multiplied by 10. And this whole guy has to be multiplied by 3. And that's what I'm showing you right here, right there. So after I do that multiplication and I rewrite the equations, this is what I end up with. 20x plus 30y is equal to negative 160. 5x minus 30y is equal to 90. Now, look, I've created the two equations and everything was legal, and they drop out. The y values drop out. So when I add these guys, I end up with 20x plus 15x, which is 35x. Add these guys, I get a negative 70. Divide both sides by 35, and I get a negative 2. That's the first part of my answer. Boom, right there. I get to take that negative 2, and I can plug it into either one of the original equations or the second ones. It doesn't really matter. But because these are a little bit easier and the numbers are smaller, that's the one I'm going to use. In fact, I'm going to use this guy right here. So I took my negative 2, and I'm plugging it in here for x, and there it is right here. There's my 3y and a negative 16. 2 times negative 2 is negative 4, and I'm solving for y here. Take the negative 4 and throw it on the other side. I get a negative 12 over there, and there's a 3y. Divide both sides by 3, and I get y is equal to negative 4. And there's the second component for my answer. So not bad at all. So this is the video, and this is part 2. Okay.